dimethyl sulfide, a molecule that on Earth is produced by only one thing: life. The James Webb Space Telescope just detected it in the atmosphere of a planet 120 light-years away. Not water, not methane, not the usual suspects we've been chasing for decades, but a gas that bacteria and plankton pump into Earth's oceans every single day. A chemical signature so specific, so biological, that finding it anywhere else in the universe should be impossible, unless something is alive out there. The planet is called K2-18b. It orbits a dim red dwarf in the constellation Leo. Its surface temperature hovers around 49 degrees Celsius, warm but not scorching. Its atmosphere is thick with hydrogen and water vapor, and buried in the spectral data, among the familiar peaks and valleys of chemistry, sits that one undeniable signal: 99.7% confidence, less than a 0.3% chance of error. If these readings are correct, we're not alone, and the implications are staggering, because this isn't just about one planet, it's about what this discovery means for the rest of the galaxy. Let's break down what Webb actually found. The anomaly in the data. The discovery came quietly, buried in streams of light captured by the James Webb Space Telescope. At Cambridge University, Dr. Niku Madhusudan studied faint ripples in the data, tiny dips in starlight that revealed the atmosphere of K2-18b as it passed in front of its star. For weeks, his team saw only familiar signs: water vapor, methane, carbon dioxide, the usual chemistry of a distant world. Then one signal changed everything. It was dimethyl sulfide, a compound that on Earth is produced exclusively by life: plankton, microbes, ocean bacteria. It doesn't emerge from volcanoes or storms. There's no geological process that creates it. Only biology makes it. The numbers held strong, a 99.7% confidence level. In scientific terms, that's not a hint. That's confirmation. K2-18b orbits a small red dwarf star in Leo. It's about 8 times Earth's mass, massive enough to keep a thick atmosphere, but too small to become a gas giant like Neptune. Its conditions sit in a perfect balance: warm, stable, and shielded. Not too hot, not too cold. A world built for endurance, and just maybe, for life. A world beneath crimson skies. K2-18b isn't a rocky Earth twin. It belongs to a different class entirely, called a Hycean world. Part hydrogen atmosphere, part global ocean. Imagine a planet wrapped in thick clouds, its skies tinted red by a faint dwarf sun. Below those clouds stretches an ocean so vast, it makes Earth's seas look like puddles. Despite its alien nature, the planet's temperature, around 49 degrees Celsius, is surprisingly gentle in cosmic terms. The hydrogen atmosphere acts like an insulator, spreading warmth evenly across the surface. It prevents the wild extremes that scorch one hemisphere and freeze another. No ice ages, no deserts. The planet lives in permanent balance. This stability could be paradise for evolution. On Earth, life clawed its way forward through extinction and chaos, mass die-offs, climate swings, asteroid impacts. On K2-18b, life could grow unbroken over billions of years. Its sun, a red dwarf, burns softly but steadily. Unlike our yellow star, which will die in 5 billion years, red dwarfs live for trillions of years. That gives life an unimaginable luxury: time. Time to adapt, time to diversify, time to become complex. How Webb saw the invisible. To uncover such a secret, humanity built the most powerful eye ever made. The James Webb Space Telescope orbits 1 million miles from Earth, floating at a gravitational balance point called L2, where the pull of the Sun and Earth cancel out perfectly. There, protected by a 5-layer sunshield colder than Pluto, Webb stares into infinity. Its 18 golden mirrors form a single perfect lens, tuned to detect infrared light invisible to human eyes. When K2-18b drifted between its star and Webb, a fraction of starlight passed through the planet's atmosphere before reaching the telescope. Each molecule in the air absorbed different wavelengths, leaving tiny gaps in the spectrum. By decoding those gaps, Webb could read the planet's chemistry like a barcode written in light, and when the computer matched one of those barcodes to dimethyl sulfide, scientists froze. They were looking at a pattern not made by geology or physics, but by life itself, the breath of a living planet. On most dead worlds, the atmosphere eventually falls silent. Methane, carbon dioxide, water vapor all settle into a steady rhythm dictated only by physics. Scientists call this chemical equilibrium, but K218b refused to obey that law. When Webb's instruments analyzed its atmosphere, they found instability. Methane levels rose and fell. Carbon dioxide fluctuated. Water vapor shifted in ways no random process could explain. Even more striking, ammonia, a gas expected to be abundant, was mysteriously missing. Something was using it up. On Earth, that something is life. Microbes consume ammonia, recycle it, and release byproducts that sustain the rest of the biosphere. The same chemical dance appeared to be happening 120 light-years away. To scientists, this was the signature of activity, not speculation, not maybe. For the first time in history, the evidence was measurable. Life isn't a theory anymore. It's chemistry we can see. A paradise of pressure and depth. Beneath K2-18b's dim red skies lies an ocean that may stretch for hundreds of miles deep. Water mixes with hydrogen under crushing pressure, forming strange liquids unlike anything on Earth. In the upper layers, rain could fall as mist instead of drops. Deeper down, pressure turns carbon into diamonds that sink through crimson clouds into dark seas below. Despite its alien nature, this world may be perfect for life. Organisms here could breathe hydrogen, feed on methane, and draw energy from heat rather than sunlight. Life would adapt to chemistry, not climate. And here's the kicker: if life can exist here, it can exist anywhere. Red dwarfs like K2-18b's parent star make up 70% of all stars in our galaxy. If even a fraction of them host planets like this, then the Milky Way isn't silent, it's alive. The eternal twilight. K2-18b's year lasts only 33 Earth days. It orbits so close to its star that one side is forever locked in daylight while the other sleeps in endless night. But thanks to its dense hydrogen blanket, heat from the sunlit side flows across the planet, creating a world bathed in perpetual twilight. Here, there are no sunrises, no sunsets, only gradients. The horizon glows in shades of copper and rose. Clouds shimmer with violet light. The ocean reflects the dim red sun like a mirror of liquid fire. To stand there would feel like being caught between two eternities, light and dark, both endless, both calm. In this slow, unchanging world, life would move differently. No rush, no seasons, no frantic race for survival. Evolution would favor endurance over speed, adaptation over aggression. Plants might be deep purple or black, evolved to absorb every photon of red light. Animals could sense vibrations through thick air instead of seeing, a ripple in the water, a pulse in the ground. That's how life would communicate here. And under that dim sun, everything would grow not in chaos, but in harmony. A civilization of cells built on patience, seeing life in light. Each time K2-18b passes in front of its star, a fraction of starlight filters through its atmosphere. And in that thin beam, Webb can read an entire planet's story. The telescope's instruments record how different wavelengths are absorbed by gases in the air. Those tiny dips spell out familiar names: dimethyl sulfide, methane, carbon dioxide, a trio that on Earth always points to one thing: life. For decades, scientists assumed red dwarf stars were too weak and too violent to host habitable worlds. Their faint glow and occasional flares made them seem hostile to biology. But Webb's discoveries have flipped that script entirely. These tiny ancient stars may actually be the cradles of life throughout the galaxy. Their gentle, steady light gives planets like K2-18b stability that our sun could never promise. If you stood on K2-18b, your eyes would never see a clear edge between ocean and cloud. Every breath of mist would taste faintly metallic. Every wave would glow with a copper sheen. It wouldn't feel like being on a planet. It would feel like floating inside something alive, a conversation across time. Here's the strangest truth. The light Webb analyzed from K2-18b isn't from today. It began its journey in 1905, the same year Einstein published his theory of relativity. When humanity was just beginning to send radio waves into the sky, the telescope is, in a very real sense, looking into the past. That means every photon Webb caught was a time capsule. When the light left that distant world, it carried the imprint of gases, oceans, and maybe even life as they were more than a century ago. So what we're seeing now isn't what's happening on K2-18b today. We're seeing how it was, a frozen moment in the life of a living planet. Astronomy isn't just observation, it's a memory. Every star, every world, every reflection in space shows us the universe not as it is, but as it was. And within that memory, K2-18b tells a familiar story. Its atmospheric chemistry is out of balance in the same way Earth's is, a state scientists call disequilibrium, and it's a hallmark of life. Life constantly disrupts chemistry. It breathes in, breathes out, recycles, reshapes, so across 120 light-years, two worlds seem to share the same rhythm. The red dwarf burns softly, a patient provider. The planet responds, absorbing, exhaling, renewing. It's not just physics anymore. It's a partnership, a duet between fire and breath, between energy and existence, the hidden oceans below. Beneath K2-18b's thick hydrogen sky lies an ocean so vast that it may have no bottom as we understand it. Hundreds of kilometers deep, it blurs the boundary between atmosphere and sea. Near the top, the waters glow faintly red, illuminated by filtered starlight. But as you descend, light fades and pressure rises to impossible levels. Down there, chemistry becomes destiny. Hydrogen fuses with carbon, forming exotic liquids and molecules that Earth's labs can only dream of replicating. At these depths, the laws of chemistry begin to resemble biology. Molecules twist, merge, and sometimes divide. The first slow steps toward self-replication. On Earth, life began in chaos. Volcanic violence, lightning storms, oceans boiling with energy. But K2-18b has had billions of years of calm. Where Earth forced life to fight for survival, K2-18b may have let it grow unchallenged, refining itself into complexity over endless eons. Though Webb can't peer through the planet's cloudy veil, its instruments catch faint traces that betray what happens beneath. Methane and carbon dioxide rise from the depths. DMS drifts upward like a chemical signal flare. In those dark, pressurized depths, entire ecosystems could thrive, not needing sunlight, but drawing energy from chemistry itself. It's a vision both alien and intimate, the same spark that once flickered in Earth's seas, now glowing softly in a crimson world far away. The cosmic circle. Every discovery adds another verse to a single story, the universe becoming aware of its own life. When light from K2-18b reached Webb, it completed a cosmic circle, the cosmos observing itself through one of its creations. The first breath on that distant world may have been the echo of the same principle that shaped us. Survival, adaptation, awareness, we and they. Different chemistries, same idea. Webb didn't just find a planet, it found a connection. The cosmos, long thought silent, is alive with hidden songs. And as our signals travel outward, radio waves, television, the pulse of human civilization, they might already be brushing the shores of K2-18b. If someone, or something there, has learned to listen, perhaps they've already heard us. Until that day, Webb continues to gaze into eternity, catching whispers of life across time and space. And each time it does, the universe becomes a little less lonely. We're witnessing the moment humanity stopped being alone in the universe. Every new Webb observation brings us closer to confirming what K2-18b is trying to tell us. If you want to be here when that confirmation drops, hit subscribe, because this story is just beginning, and you won't want to miss what comes next.